In part 2 of this series, I'll continue to show you how to solve exact first-order differential equations. In question 1, they want us to solve 2xy dy minus 4x dx plus y squared dx is equal to 0, such that x is equal to 1 when y is equal to 2. The first thing that I'll do is group together the first and the third term, and then transpose or move this term over to the right side. Let me show you what I mean. I have 2xy dy plus y squared dx is equal to 4x dx. In case you're confused, I moved this term over to the right side and I brought together this term with this term. Look closely at the left side here. We have two terms and it sort of looks like x dy plus y dx. In fact, the only difference is that we have 2xy and in this term we have y squared. So instead of dxy, the derivative of the function xy squared will actually give you the following, and I'll show you. Using the product rule, if I leave this the way it is and take the derivative of y with respect to x, I end up with 2y dy over dx. And similarly, if now I leave y to the power of 2 the way it is and derive x, I end up with dx over dx, or simply y squared. This expression and this expression look very similar, except the only difference is that we have dx here. So if I multiply this derivative by dx, this dx disappears and we end up with 1 here, and the right side stays the way it is, where I have 4x dx. Therefore, what I'm highlighting right here can be replaced with xy squared, where I have xy squared is equal to 4x dx. I'll also have to integrate this part with respect to x, and if I do that, I end up with 1 plus 1, so I have 2 divided by 2, giving me 2x squared plus c and xy squared on the left side. All I have to do now is bring this term over and then substitute my boundaries, which was at 1 and 2. So I have xy squared minus 2x squared is equal to c. Substituting x is equal to 1 and y is equal to 2, I end up with 1 times 2 to the power of 2, which is 4, minus 2 times 1, and this gives me 4 minus 2, which is 2. Therefore, x y squared minus 2x squared is equal to 2. Let's move on to question 2. In question 2, they want us to solve 5x is equal to 2y squared plus 4xy, and this y becomes dy over dx, such that x is equal to 1 when y is equal to 4. The first thing that I'll do, as mentioned, is replace y prime with dy over dx. So I have dx is equal to 2y squared plus 4xy dy over dx. I want to clear the denominator, so I'll multiply everything by dx. And if I do that, I end up with dx multiplied to 5x, dx beside this term, and this dx goes away. So let me clean this up for you. I have 5x dx is equal to 2y squared dx plus 4xy dy. Following this step, I'll factor out a 2 from both of these terms on the right side. And if I do that, I end up with 2 bracket y squared dx plus 2xy dy. I want you to take a good look at what I just found. Remember in question 1 when we had 2xy dy plus y squared dx? Well, that's the exact same thing we have here. We have y squared dx and we have 2xy dy. And we found that taking the derivative of xy squared will give us this expression. This tells me that the right side is done. All I have to do now is worry about the left side, and I can do that by taking the integral of the left side and of the right side. I already know the integral of this. It's going to be xy squared. So I have 2 times xy squared plus c. And the left side isn't trouble. I'll just add 1 to this exponent, making it x to the power of 2. So I have 5 over 2 x to the power of 2. I can evaluate this at its boundaries at 1 and 4. So I have x is equal to 1 and y is equal to 4, and I can solve for c. Of course, I can bring this over, but I don't need to. If you want to, it'll look like this. We have 5 over 2 times 1 squared minus 2 times 1, and this y is squared, so 4 times 4 is equal to 16, which is equal to c. Using my calculator now, I can find out what this is equal to. 5 over 2 times 1, which I'll just leave as 5 over 2, and 2 times 16 is 32, negative 59 over 2. So c is equal to negative 59 over 2. Let me write this down formally. I have 5 over 2 x squared is equal to 2, and I'm just rewriting this with negative 59 in place of c, xy squared plus negative 59 over 2. I can multiply this whole thing now by 2. That will clear the denominators. And we end up with 5x squared is equal to 4xy squared minus 59. This represents the solution to question 2, and that is how to solve exact first-order differential equations.